Good morning to everybody, and you are welcome to the Thermo SIG report that I will present on behalf of other.
Yeah, go a little
of other Thermo SIG members as listed on this slide. Jasper Van Vladen is the co-leader of the Thermo SIG. Klaus Möller from the University of Cape Town and Richard Szczepański from the KBC are both experts in the field of thermodynamics and also members of Thermo SIG for many years. And last but not least, Michel Pons, our Chief Technology Officer till now at least. Yes, that are the members of Thermo SIG. What is Thermo SIG? It is a special interest group from thermodynamics with the aim to develop, maintain, and promote thermodynamic interface specification. The list of the documents currently contains the interfaces listed here. First, the physical property interface version 1.0. It was deprecated several years ago, but is still in use in some application. The second one is physical property interface specification version 1.1. This is our main working document. We are trying to steadily improve. In 2019, we have released this custom data interface specification. That is a common interface which could be used for different various purposes within the K-pop environment, but still the main usage of it seems to be the interaction between PMEs and property packages, and of that reason this interface also is in the scope of Thermo SIG. Last year, we have also prepared a draft of the new chemical reaction interface specification version 1.1. It is practically ready for publication, except some references to the common manager interface, and we are waiting for the approval of that interface to include references and to publish it. Several years ago, we have also prepared a draft for the so-called compound server interface specification. This interface would significantly facilitate access to pure compounds properties, but till now we have not found a sound business case for its use, and for that reason we keep it on hold. And there are many other documents and materials that also fall into the scope of Thermo SIG. Our key responsibilities are listed here. First is to maintain and manage active interface specification. The main points here is to provide revisions to improve the design performance and robustness of this active specification based on the user feedback. And second, to provide errata and clarification and to integrate them into the current specification. The second key responsibility is to assess and to prioritize on expansions of thermodynamic interfaces. And the next point is to help the CLAN members in the developments of their own implementation of thermodynamic interfaces. And in terms, this includes to provide advices how to migrate from deprecated to active interfaces, how to advise how to implement fully new interfaces, as well as to assist in analysis of interoperability issues. And last year, as CLAN has decided to develop the compliancy test suite, we have now got an additional key responsibility to prepare to define the compliancy tests for thermodynamic interface specification. And that was actually our main activity last year. It was expected that the preparation of tests for thermodynamic interfaces to be a big task, which will require much efforts. And to accomplish this task, we have organized our 2 hours weekly online meetings to discuss the issues between the members of Thermo SIG, as listed here. Much work has also been done offline, mainly by Michael and Jasper for the preparation of draft materials. Björn is also a member of Thermo SIG, but he could not participate on our meetings this year. Well, now to the summary of our main activities in the last year. First, we have finished the specification document for the common manager interface. The draft has been finalized. It is a common interface, not only restricted to the manager of chemical reaction packages, and of that reason, it will be better placed by the MNT SIG, and of that reason, we have handed it over to the MNT SIG, and now waiting for the decision for the approval of that interface, because we needed to incorporate in the chemical reaction interface specification in order to publish it. And the main focus this year was put on specification of consistency tests. As I said, it was expected to be a big task. Still, we have really underestimated the efforts needed as well as time. The main reason was that we have discovered many of ambiguities in the specification or unclarities in the specification document, and so we had also to fix this issue to prepare a new version of errata and clarification documents. Well, before going into details about the certification process, let me address your attention now to the 2 other interfaces. The first one is the custom data interface specification. As I said, it has been published already in November 2019. And actually, it provides a universal caching mechanism that could be used for different purposes within the CAPOPEN environment to facilitate interaction between the components involved. Surely one can always implement its own private caching mechanism on the PMC side, but such an implementation will have significant drawbacks, mainly because PMC has no possibility to track the lifespan of the object defined on the PME side, and of this reason, the proposed custom data interface allows to overcome these difficulties. Till now, to our knowledge, there are only 2 implementations of this interface. One on the PME side, Coffee from Amsterdam, and another one in the ProTreat thermal package from Optimized Gas Treating incorporation on the PMC side. And at this point, we would like to promote a broader use of this custom data interface of different reasons, mainly, especially on the PME side, because implementation of the support of that interface on the PME side is rather straightforward. It's a small interface, and it is to be noted here that implementation of support for these interfaces is required in the future for PMEs that will use the revised chemical reaction interface. And another reason may be that implementation of custom data interface might become mandatory on material objects in the future versions of the open standard. The next interface I would like to mention here is the chemical reaction interface specification. As I said, the draft has already been prepared last year. Now we are waiting, and we have handed the prepared draft of the common manager interface to MNT, and MNT needs now to submit that interface for request for comments, so that upon publication of that manager common interface, references to it incorporated in the revised chemical reactions, chemical reaction interface specification, and then the revised document will be then submitted for the second final RC. Well, now to the certification support, our main activity this year. This year we have focused on the preparation of test for the property package as PMT under test. Still, it has to be mentioned already here that there are some other components within the Cape Open environment that utilize, that exercise thermodynamics call, unit operation PMC, PME servo socket, as well as PME unit socket. And in the table presented on the slide, you see the symmetry as well as asymmetry for different components or interaction between the components to be considered. We see the overlap between different types of interactions as well as main differences. For example, either the thermodynamics call are generated or received by different components to be tested, or either the material object is to be provided by a component or to be validated. And the main problem in the preparation of this certification test was actually the variety of different scenarios to be considered or to be at least accounted for in the future, depending which components, because any test depends first on the context in which this test is to be done. Second, we have to account what is the color and what is the color. And third point to be accounted for is also what component is the component to be tested and what is the tester component. All this results in a large number of scenarios to be considered, and all of them had to be accounted for in our analysis. And actually this slows down the development of tests at the moment. But we hope that this will simplify our work if we start with implementation of tests for other components like PME, thermosocket, or PME unit. Well, now to the certification support details. First, we have formulated the testability paradigm that states that any requirement in the specification should be testable. And we have realized very soon that that is not really the case in the existing specification document. And this has motivated us to start parallel to development of the consistency test, to start with the extension of our errata and clarification, trying to fix discovered issues. The good news is that no major issue has been found that would require the immediate release of a new version of the specification. Well, we could expect that because after all, the open application are successfully running over many years. And so we expect that the developers have overcome unclarities in the document specification, they made proper assumption, and the practical interoperability has been proven over years. Nevertheless, we have found a large number of clarification during preparation of test, and we expect that the current version of errata and clarification will be a big detailed document, and which has to be submitted for request for comments. And we would also appreciate comments, corrections, improvements from the reviewer very, very much in the future. Because of its size as well as because of intensive cross-referencing in the errata and clarification, it will make less sense to publish errata and clarification as a separate document, and so we are planning to incorporate it directly in the new revision of the interface specification for better readability. And it has to be noted here also that most of issues found are just a clarification. Still, there are also some issues that has required change of the contract, but hopefully these are minor issues for the developers. Now some more details about errata clarification, about issues found. First, we have realized that the responsibility between the calling and callers has not been clearly stated in the specification for the thermodynamics call if arguments are passed. Well, it is not a big issue for the practical usage. After all, both PME and PMP, in this case property package, can perform their own validity check just to ensure that the request for thermodynamic property is valid. But this is a crucial issue for testing because the behavior is not clearly defined in that case, and so we had to fix that issue. And in fact, we stated now that it's a responsibility of the caller to ensure that the arguments passed into the thermodynamic call are valid. In particular, this means that the caller cannot guess anymore which phase labels, for example, or compounds identifier can be passed in the call. And this simplifies the interpretation on the PMC side on one. And what is much more important, this allowed us to define the compliancy test in a straightforward and transparent manner. Yeah. Next point we have found is that there are too many unclear or too implicit requirements. A simple example of that. The simple example here is whether or not the PMC, in our case, the property package, may raise a not implemented exception. This raises a question: is that such an implementation is a valid implementation? Should it be considered as consistent or not? Furthermore, this implies also the question whether for the case if the argument, if the result of the call is a list of identifiers to be returned, whether this list might be empty or not. The definition or the answer on these questions is not so evident as one may expect, and actually depends on the context in which this call is made. But to enable the consistency test, one has to still to define unambiguous behavior, standard behavior, and of that reason we have come to the conclusion to forbid now the raising of not implemented exception on one side, on another side to allow for returning an empty list of identifiers as a particular example of problems we have faced. Another big issues we have found in the specification was that the phase presence, or in other words, the status of phase is not clearly described in the specification, and of that reason we have added a whole new chapter that describes the proper behavior in details and allows to define the consistency test for that case. And also we have added a detailed description of consistency requirements for the following group of related methods as listed here. Again, with the primary goal to enable definition of the appropriate consistency. Furthermore, we have found that there are many issues are not clearly described behavior of the material object, the responsibility of the material object was not clearly described in the specification, and we also have added a separate chapter devoted to these issues. Additionally, we have also realized that it is clear that the standard does not prescribe the precise behavior of the material object, and the different implementation of a material object may strongly differ in the sense which additional services are supported by the material object. And of that reason, we have now added some advices and hints what is allowed for the material object to extend its usability and what is forbidden. The key responsibility, additional extra functionality of a material object is that it is now obliged to support basis conversion for the properties if some of bases are not. So the material object provides this service to the consumer of thermodynamic data, as well as a material object is also obliged to support interconversion between flows and fraction if the requests units do not correspond to that unit expected by the property package. And extra functionality as a material object may also support additional services. If, for example, the property package does provide volume but not density, then the material object may perform the required conversion on the fly using basic thermodynamic relationship and just to extend the applicability of a proper package. So all these things have been now clarified and described in the errata and clarification document. Furthermore, we have made a clear distinction between static and dynamic information that is kept on the material object, because surely there are some data that are context dependent, and they have to be refreshed each time if the context changes. And there are some other, like face labels, for example, that as static for the connected property package, as long as the configuration of property package does not change. All this has allowed us to define in total 72 consistency tests. Well, we have assisted to MNT SIG by the preparation of tests for ICAP identification. And the next 4 interfaces are specific to specific thermodynamic interfaces, and they have been implemented by the Thermo SIG alone. We have also started with the development of consistency tests for the 2 remaining interfaces, ICAP thermo property routine and ICAP thermo equilibrium routine. Much progress has been achieved also here, but this work has not been yet finished. Well, and at this place, I would also mention that much work has been done by Michel by the preparation of the draft material for the extraction of data from the existing specification to define the number and the content of tests to be done. And so we come to the outlook for the next year. Well, we will continue our support for certification purposes, and with the primary goal to define the remaining test for the property package PMC. And after that, we are planning to start work on the PME and unit PMC testing. Parallel to that, we will continue maintenance and management of existing interface specification in the sense with the aim to finalize errata and clarification documents. And the next point is the next goal is to publish chemical reaction interface specification after adding references to the manager common interface, launching IFC, publication of IDL, and disseminating of the documents. These are our goals for the next year. And now I'm at the end of my presentation. Thank you very much for your attention.
Thank you, Sergej.